We're going to take a look at natural logarithms today, but first we're going to start off by looking at a special number called e. Yes, there's a number called e. Now, you've seen where we've dealt with the um, equation where if you put some money in and you earn some interest on it and it's compounded so many times a year, how much you're going to get out. So suppose we did a very unique situation. Suppose we invested $1, which would be your P, for 1 year, so that means N is 1. And we're going to invest it at 100% interest rate. So that means R as a decimal would be 1.00. So if we plug in 1 for P, 1 for R, 1 for T, we end up getting this. So now, suppose we went ahead and changed the number of times it's compounded per year, which is n. So if n is 1, if we plug in 1, we would get this. Well, we just get 1 plus 1 raised to the first power, we get 2. If we did it semi-annually, twice a year, we get 2 plus a half raised to the second power, and we get 2 1/4. We could have chose quarterly. And if we do it quarterly, n would be 4, and we would get this. We type it in, we get this here. If n is 12, we type it in, and we would get this here. Notice these numbers are going up as you compound it more often, but it's not going up real fast. So if we went ahead and plugged in 52 for n, we would get this, type that into our calculator, we would get this. If we typed in 365, we would get this. If we typed in hourly, which would be 8,760 for n, we would get this. If we did every minute and then every second, we would get these. You can see these numbers are starting to level out. Yes, they're slowly getting bigger, but leveling out at a certain number. If you did that forever, you would get this right here. And it still goes on forever. This is your approximation of the number e. Now, e is the second most common irrational number next to the number pi. Now, mathematicians have no idea why pi and why e keep showing up in so many unrelated areas of mathematics, but they do know they keep showing up. So they both have special names. Yes, pi shows up in more things other than just circles and trig stuff. Pi shows up in many other things, but we are not getting into that. Same idea with e. E shows up in so many things in mathematics. The number e is referred to as the natural number e. So if we were doing exponential functions with a growth factor of e, that would be referred to as a natural exponential function. So if you have, and we'll deal with that here in a bit. So if you had y is equal to e to the x, that is your natural, if I can write here, sorry, y equals e to the x is your natural exponential, and we're not writing, natural exponential function. So if you're using a logarithm with base e, like we are here, log base e of x, we would write that as ln of x. That's referred to as your natural logarithm. And you'll have an ln button on your calculator, which is just below your log button, log button. So your calculator likes your common log, the log button on your calculator, and it likes natural logs, or log base e. So the inverse of any exponential function is a logarithmic function. So the inverse of your natural exponential function is your natural log of x, which is your natural logarithmic function. So If you go second ln, you get your e to the x. So go second ln on your calculator, and then type in the exponent of 0.5, and you should get this. And then type in the rest of these. Second ln on your calculator, negative 0.8. Then just hit your ln button, hit 3, and then enter. Or just hit your ln button, type in 1 divided by 4, or 1/4, and hit enter, and you should get those. Now, we have an exponential equation. We could write it in a logarithmic equation. If we look at this first one, we could go log of our base. Remember, your base is what your exponent's on. And then the exponent goes on one side by itself. And then what was over here goes after your logarithm. Now, because we have log base e, we could just write that as ln of 23. So, looking at the next one, we could go log of our base of e, put our exponent on the other side. What was on one side here, the 6, goes after your log. So, because we have on log base e, we could write that as a natural log. Here, working backwards, I'm going to go ahead and rewrite this as a log base e, because natural log is log base e of x is equal to this. So now, remember that to go from a log form to an exponential form, you got to take your base, which is e, swing it over, hit your exponent up. And so we would get this. Same idea over here on the right. Go ahead and rewrite this so that this is a normal log. So go log base e of x is equal to 2 1/4. Then you can always take your base, swing it over, and hit your exponent up. And then we get this. Now, down below here, e and ln undo each other, so it leaves you just with 21. Here, ln and e still undo each other, leaves you just with x plus 3. So e and ln undo each other, that's in 7. E and ln undo each other, leaves you just with your exponent. So e and ln undo each other. So we're now going to go ahead and try to solve this. So to solve this for x, I need to try to get this part on one side by itself. So I'd have to get rid of the plus 4, and I'd have to get rid of the timesing by 3. So I'm going to go ahead and subtract 4 from both sides. Get rid of the 3, I'm going to go ahead and divide by 3. Now that I have e to a power equaling something, I know I have to go ahead and use a logarithm because my variable's in the exponent. But because my base is e, I'm going to choose to use a natural log. So I'm going to take the natural log of the left, and if I do something on the left, I got to do it on the right, so I'll take the natural log of the right. Remember, e and ln undo each other, so the only thing we're left with is that negative 2x over there, still with our natural log of 2 over there. Now we can go ahead and get x by itself by multiplying both sides by negative 1/2. That's your calculator ready form. You type it in to get your approximation. So yes, you'll be looking for calculator ready form just like you were in some of the earlier sections. This one here, we want to get your e to a power by itself, so you got to undo your plus 5, and you got to undo your 2, so subtract 5 from both sides, undo timesing by 2, so divide both sides by 2. Because it's e to a power, we're going to, in our variables in the exponent, we have to use a logarithm, but because our base is e, we're going to go ahead and use the natural log. Take the natural log of both sides. Remember, e and ln undo each other. Then go ahead and get x totally by itself by multiplying by negative 1/2. Calculator ready form, we type it in and we get our answer. And here we have a polar bear in a blizzard.